So far we've looked at how to tell the difference between a linear relationship and a nonlinear relationship, mainly realizing that for a linear relationship, um, there is a constant rate of change. And that means that if you're going to graph it, you're going to see a straight line. Or if you're looking at values in a table of values, the first differences are going to be the same. We've also looked at how to pick off the initial value and the rate of change of a linear relationship from different representations, so from words, from tables of values, and from graphs. So what I would like to do today is kind of put that together and come up with some algebraic ways of modeling linear relationships. So coming up with equations to model linear relationships. And to show you how this works, I'm gonna bring you back to a example of a linear relationship that we looked at the very beginning of the unit, and that is talking about pizza. So this is, I got this off the website for Mamma Mia's Pizza over on Front Road, and this is how much they charge for their pizzas. So let's, for example, look at an extra large pizza. So if I'm going to get an extra large pizza with just tomato sauce and cheese, the pizza is going to cost me $26.50. From there, there's a bunch of specials I could choose. But if I just wanted to choose my own toppings and create my own pizza, for the extra large pizza, what I would have to do is I would have to add an extra $1.50 per topping. Okay, so based on what we've talked about so far, I can pick up some key information there. So first of all, I know that in this situation, the initial value is $26.50 because before I put on any toppings, if I just buy a base crust with cheese and tomato sauce, it's going to cost me $26.50. However, the rate of change is going to be $1.50 per topping. So every time I add a topping, I'm going to add on $1.50. So $1.50 per topping is our rate of change. And this is an actual linear relationship that I probably do in my head often, and you may have already thought about this kind of situation as well. So if I'm trying to figure out how much a pizza is going to cost, I think about how many toppings is going to be on the pizza. So for example, if I have 0 toppings, then the cost is going to be $26.50. If I'm going to add a topping, then my cost is going to be $26.50 plus the additional $1.50 for that one topping. So that's going to take me up to $28. If I decide to get 2 toppings on the pizza, then the cost is going to be still that $26.50 for the crust, the cheese, and the sauce. And then I'm going to add $1.50 for one topping and then $1.50 for another topping. And another way of writing that, instead of writing cost, I can just write that as C. And then I've got the $26.50, which is the initial value. And then I'm going to take that $1.50 and I'm just going to times it by 2. It just makes it a little bit shorter to write it that way. Keeping in mind that the 2 is actually just the number of toppings that we chose to put on it. For 3 toppings, again, same thing. Our cost is going to be equal to $26.50 plus $1.50 plus $1.50 plus $1.50. But this is getting long to write. So again, I'm going to shorten it down. I'm going to say the cost, C, is equal to $26.50 plus $1.50 times 3. Keeping in mind, again, that the 3 is the number of toppings. So this is fine if we have 1 or 2 or 3 toppings. Let's say I wanted to put on 10 toppings onto the pizza. Then it becomes a little bit more complicated, and I don't want to write out $1.50 10 times. So what we can do is we can take this idea here and we can generalize it to come up with an equation to model the cost of a pizza. So let's say I have n toppings. So this could be 10, this could be 15, this could be 100. Maybe not 100 pizza toppings on a pizza, but you get the idea there. So if I have n toppings, some number of toppings, the cost is always going to be equal to $26.50, so the initial value, plus $1.50 times the number of toppings. And then using this equation that we've created, we can always figure out what the cost of our pizza is going to be based on the number of toppings that we pick. Okay? And I wanted to point out too that this equation here is the exact same as this equation here. So if we wanted to, we could take the number of toppings, figure out what the cost for that would be first. So it would take $1.50 times the number of toppings, and then I could tag on that initial value of $26.50 at the end. So it doesn't matter which way I write it. Either way, I'm going to be able to figure out what the cost of the number of the pizza is going to be. So using this as a model, we can actually generalize this for all linear relationships. So if I can pick off, for a linear relationship, if I can pick off what the rate of change is, and I can pick off what the initial value is, and if I know what my dependent and independent variable are, so if I go back to the pizza example, the independent variable would be the number of toppings, because that's what I'm in control of. That's what I'm determining. And the cost is going to be dependent on that. So that's going to be my dependent variable. So it's always going to be your dependent variable is equal to the rate of change times the independent variable plus the initial value. So the dependent variable, I often call that y, because we write that on the y-axis, and it's our y column in our table of values. The rate of change we know is equal to rise over run. The independent variable, we always write on the x-axis of our graph, or the first column of our table of values, x column. And then the initial value we can always pick off by looking at where the equation is equal to, what value of y goes with the x value equal to 0. And I just wanted to point out too, again, that you can write it either way. So you can write y is equal to the rate of change x plus the initial value, or you can write it as y is equal to the initial value plus the rate of change times x. Okay, so this is the general equation for a linear relationship. And what we're going to do is we're going to practice going from different representations. So again, from words, from graphs, and from tables. We're going to pick off the dependent, independent variables, the rate of change, and the initial value. And once we've determined all those things, then we can create an equation to model a linear relationship.